Greetings! In our second video in this new YouTube channel, we three hosts thought that we would choose one comet that we each observed in our lives and spend several minutes discussing that comet from our own perspectives. This will help further introduce ourselves and give some information about comets that may be of interest to both people avidly interested in comets and people who know very little about comets but are eager to learn more about them. This is Dan Green, and I'll be discussing the comet C/1983 IRAS-Araki-Alcock. This comet was found on 1983 April 25th in images obtained with the then new infrared astronomy satellite, known by its acronym IRAS, or just called IRAS, but it was reported as a fast-moving object that was presumed to be asteroidal, not cometary. Comets are distinguished from asteroids through their having an atmosphere or coma and/or a tail, and their discoveries are handled differently. At the time, I was working as a young assistant to Dr. Brian Marsden, who directed both the Central Bureau for Astronomical Telegrams, responsible for announcing new comet discoveries since 1882, and the Minor Planet Center, which together have archived all comet positions and orbits for a half-century. IAU Circular 3796, shown here, announced the discovery to the world, which also went out, as was customary then, by telegram. Oddly, the IRAS discovery was reported to observers in an apparent desire to obtain ground-based confirming observations before reporting to the Central Bureau, but the Central Bureau only learned of the IRAS discovery from observers, notably from Jim Gibson at Palomar in Southern California, who supplied us with positions and times. Recall that this was before the World Wide Web and before traditional internet email. Many astronomers were then using a restricted form of email available in the academic and government arenas and known as DECnet. Before the Central Bureau got positions for the IRAS object, reports of independent visual discoveries made on May 3rd by George Alcock in England and by Junichi Araki in Japan were received, together with positions and brightness estimates that indicated the comet was an easy binocular object and near the limit of naked eye visibility from a dark sky. The report from Alcock came via phone call to fellow co-host Charles Morris, who then alerted us at the Central Bureau. What is interesting is that Alcock discovered the comet with his 15 by 80 binoculars from indoors, looking out through a closed window. Araki's report was telegraphed from Tokyo Observatory. On the evening that we received Alcock's report, I went to the roof of Harvard Observatory and made visual measurements of the comet with my binoculars. The name IRAS-Araki-Alcock comes from the three discoverers in chronological order of their finding the comet. It was also given a provisional designation, 1983D, meaning that it was the fourth comet discovered and confirmed in the year 1983. It would later be given the permanent designation 1983 Roman numeral 7, meaning that it was the seventh comet known to have passed its perihelion in 1983, with perihelion being the closest approach to the Sun of any solar system objects in an elliptical orbit. In 1995, the comet designation system was changed to be more similar to the minor planet designation system for purposes of dealing more easily with astrometry and orbits in archival form. Astrometry is the measurement of position of celestial objects. Note that, in general, comets have much more elongated orbits about the Sun than do minor planets, but there are exceptions in both areas. Now, when I say this was a fast-moving object, I mean relatively speaking. Comets do not shoot across the sky like a shooting star or meteor that is burning up upon entry into our atmosphere. Rather, comets are really minor planets orbiting the Sun and far away from the Earth. So, like celestial objects beyond our atmosphere, comets rise and set daily, and they move with respect to the background stars, as do planets and the Moon. So the observations given on the circulars shown here give the date and time as a decimal of a day in so-called universal time, based on the Greenwich, England meridian, which all astronomers use for uniformity. And we also see coordinates called right ascension and declination, or given here as Greek letters alpha and delta, which generally compare to longitude and latitude on Earth but projected onto the sky, with stationary background stars as the reference. The brightness is given in so-called magnitudes on a scale in which the brightest nighttime star is at magnitude minus 1.5. The brightest planet Venus can reach magnitude minus 4, and the larger the number, the fainter the object. Thus, the faintest naked eye star in a dark sky is around magnitude plus 6 or plus 6.5, but in bright urban skies, the faintest naked eye star might be magnitude plus 2 or plus 4. On this scale, the full moon is near magnitude minus 12, and the stars of the Big Dipper are around magnitude plus 2 to plus 3. The brightest comet observed in the last century became almost as bright as the full moon in 1965, and Comet IRAS-Araki-Alcock would reach into the top 20, as you can see in this table of the 25 brightest comets of the last century, in terms of total visual magnitude of a comet's entire coma. Comet IRAS-Araki-Alcock was moving rather fast, indicating that it was rather close to the Earth by comet standards, creating instant excitement due to its brightness. By May 8th, the comet was a relatively easy naked-eye object for experienced observers who knew where to look in a dark sky. Preliminary orbital calculations based on the scant early astrometry suggested that the comet was rapidly approaching the Earth and would pass only about 3 million miles from the Earth on May 11th, closer than any known comet since Lexell's comet in 1770. Two additional comets have been confirmed since 1983 to have passed closer to the Earth than this comet, including medieval chronicles of Comet 55P Tempel-Tuttle in the year 1366. But in 1983, the discovery of Comet IRAS-Araki-Alcock, only days before a pretty close approach to the Earth, stretched our resources and the available technology to the limit. We had just converted 4 years earlier from computing orbits via punched cards to the use of interactive computing at a monitor with a keyboard. Announcements were still only made via printed postcard circulars and by telegram through Western Union and Western Union International. Discoveries and observations were still received mostly on paper, whether by postal mail or telegram, with the odd comet discovery report via telephone. As late as May 11th, large observatories in East Germany, Poland, Israel, and India continued to send reports of independent discoveries of this comet, and astronomers in several other countries were completely unaware of the comet's close approach to the Earth until later. So, astronomers and reporters were dependent on news from the Central Bureau for Comet IRAS-Araki-Alcock, and the printed circulars took several days to be printed and mailed to their recipients. This meant that for most people, phone calls were the only way to get information easily and quickly. The Central Bureau was absolutely swamped with hundreds of calls from reporters, planetarium personnel, professional and amateur astronomers, and even curious people unfamiliar with astronomy. This was made more difficult because Brian Marsden and I were involved heavily with observing the comet, processing incoming observations, and computing its orbit and ephemeris from the astrometry. By night, I was taking glass plate photographs at Harvard's Oak Ridge Observatory at night, developing them and measuring the comet's position for use in orbit calculations, as well as observing the comet visually and making brightness and size estimates. By day, I was helping Brian Marsden and our colleague Conrad Bardwell process and analyze observations from other observers around the world, as well as fielding questions and interviews by telephone. It was an exhausting few days, and we were fortunate to have Steve O'Meara, a writer at Sky and Telescope magazine, come in to man the telephone at times and field questions with his own expertise in observing comets. An ephemeris is a prediction of a comet's future position and brightness on specific dates for planning observations, as can be seen in IAU Circular 3799 here. The orbital elements are given above the ephemeris here and indicate that closest approach to the Sun. Perihelion occurred on 1983, May 21st, at a distance of 0.991 AU from the Sun, where 1 astronomical unit is the mean distance of the Earth from the Sun in its annual, somewhat elliptical orbit. But it just so happened that the comet was approaching its perihelion distance just 10 days after closest approach to the Earth. The comet grew brighter and larger as it approached the Earth as it moved north through the constellations Ursa Major and Ursa Minor, housing the Big and Little Dippers. And by May 11th, it rivaled the brightest stars in the Big Dipper. It never showed a tail visually, so it was just a large, fuzzy ball in the northern sky, up all night for Northern Hemisphere observers. The coma size of the comet reached some 3.5 degrees, or about 7 times larger than the apparent size of the Moon. Intrinsically, the comet was rather small and faint, thus the reason for no obvious tail visually, though there was a faint, thin tail that was photographed. But its close approach to the Earth made this small comet look very impressive indeed. Professional telescopes around the world peered into the comet's coma, including spectroscopic observations identifying molecules in the coma, with the first time that diatomic sulfur was seen in a comet, and radar observations that my group in Cambridge undertook with the large Arecibo radio telescope in Puerto Rico. After May 11th, the comet quickly receded from the Earth and moved to far southern skies as it faded rapidly. In the aftermath of the comet's close approach to the Earth, which taxed our small staff at SAO in Cambridge to the max because technology was still developing on computer and communication fronts, a big effort was made by the Central Bureau staff to quickly develop a dial-in computer service in which subscribers could access the circulars and orbital elements and ephemerides and other observations of newly discovered astronomical objects quickly and without burdening us with lots of phone calls. Circulars would thus become available in real time to people around the world as they were posted by us. But it would be a few more months before this happened, and it would be another decade before the Central Bureau began hosting one of the first worldwide websites in the world for news of comets and other newly discovered celestial objects. Comet IRAS-Araki-Alcock was thus a watershed comet in my life and in the world of cometary studies generally.